everybody, my name is Mrs. Benson and you've got Mr. Reynolds here too.
Hello.
And we've come together today to make a preview video of what we're going to be doing at the beginning of week 2. So we are going to be working on the Pendulum lab. It is the very first lab that we're going to do in this course. You are going to really be setting the stage for the rest of freshman physics because all of our labs are going to be very similar to the setup for this lab. So if you want to take it away, Mr. Reynolds, to kind of introduce us.
Sure. Okay, so what is a pendulum? Really, we just have a basic, simple pendulum set up here, which is just a weight hanging from a string. It's attached up there, and you can see at the very top, is that in the frame? You can see at the very top I have a protractor that will measure the angles, and then we've extended that down here so we can see what angle the pendulum is sitting at. And that's what we're going to investigate today. We're going to investigate whether or not the angle that I pull this out and release it from, heads up, right? If I release it from way out here, or if I release it from right here, when I change that release angle, what does that do to the time it takes for one full swing? That's our investigation. How does the release angle affect the time of one full swing? Okay, so let's just start.
So I'm going to grab a timer.
We'll gather some quick data, and so let's figure out what's a good way to get good, accurate data. So Ms. Benson and I are going to work together. The first thing we're going to do is I think I'm going to start out way out here because it's easier to measure kind of larger things. And I'm going to say 3, 2, 1, go. And on go, I'm going to release the ball, and Ms. Benson is going to click start, right? And then we're going to let it go out and back 5 times. And that way we can get a longer time interval for 5 swings. And then after we collect our data, we'll just divide that in by 5 to get the time of 1 swing. All right? So that's the plan. Ready? Let's take some data. 3, 2, 1, start. 1. We're going to do 5 swings. 2. Don't stop until 3. You get right back here. 4. And here's, get ready, and stop. So whatever you get there, write that down. We'll come back to you in a minute.
All right, so now we're going to drop it from 40 degrees. We're going to stay where we are because we want to make sure that Mr. Reynolds and I were our control variables. So he's going to drop it the exact same way every single time. And I'm going to keep time the exact same way every single time. So from 40 degrees.
Yep, here we go. This is a 40-degree trial. We're going to do it the same way. On go. 3, 2, 1, go. 1, 2, 3, 4, and here we go, and stop.
Perfect.
All right, so let's do it again. We're just going to run through these. So if you, in case you missed class, this is how you're going to get data that you're going to record in the Desmos activity. So 30-degree trial. Ready?
Ready.
3, 2, 1, go.
1, 2,
2,
3,
3,
4,
4, and 5. Good.
Yep.
20 degrees. Here we go. 20-degree trial. 3, 2, 1, go. 1, 2, 3, 4, and 5. Okay. 10-degree trial, last time. 10 degrees. 3, 2, 1, go. 1, 2, softly. 3, 4, and stop. Okay?
Perfect.
That's your data for the Pendulum Lab in case you weren't there in class. That is all. Hope that helped.